Hello everyone, welcome to TryRide, the new era of learning. This is Pack 365. In Module 2, we are discussing about A-star algorithm in AI. In previous lecture, we already discussed about it. In this lecture, we discuss AI search in depth and how the actual behavior of A-star algorithm is to implement in graph and in coding. Part B. Let's start. A-star search is an informed best first search algorithm that efficiently determines the lowest cost path between any two nodes in a directed weighted graph with non-negative edges weight. This algorithm is a variant of Dijkstra algorithm. A slight difference arises from the fact that an evolution function is used to determine which node to explore next. So usually we all know the A-star behavior it chooses the fastest path and shortest path. It considers efficient way. It is act like a same best first search like and it is a variant of Dijkstra algorithm, and we can say it chooses the lowest path to reach the goal state immediately. So let's start. It has an evolution function. So the evolution function of like f of x for the h search algorithm is the following. So here we have f of x equal to g of x plus h of x. So here the g of x may be considered the cost of arriving, and if h of x is the estimated of the heuristic. So, where g of x represents the cost to get the node x and h of x represents the estimated cost to arrive the goal node from the node x. So, from the algorithm to generate the cost result, the evolution function must be admissible, meaning that is never overestimate the cost of the arriving to the global node. So, we also do the arrival cost of the goal node. So, it charges some points. Like if we reach, like we can say instead of the A star algorithm, like takes the lowest charge. So, instead of we can say that. If we have two routes, one is taking, like we can say the commission based algorithm, like we can say the commission based process. Like if someone asking you to do your work to, yes, come to my, come here, I will take to your goal state, by taking easy routes, and I will clear your goal state, come to my here. And as someone asking come to here, like they are charging some commission, like if starting node is A, where B is considering 20 and C is considering 24, we pick the lowest price, right? We pick the lowest price and we consider to the lowest part to reach our goals in budget friendly. So like the way the A star such behavior also like the same rate. So it consider the lowest budget according to the starting node budget. Okay, it's cost. We can call as cost. So the A star algorithm is an implemented is an in a similar way to Dijkstra algorithm. Given a weighted graph with a non-negative edges weight to find the lowest cost path from a start node and S to a goal and node G to listed or used. So here an open list implemented has a priority queue and which stores the next nodes to be explored. And because this is a priority queue, the most promising candidate node, the one of with the lowest value from the evolution function, is always at the top. Initially, the only node in the list is to start node S. So we have an again closed list which stores the nodes that have already been evaluated, means visited. When a node is in the closed list, it means that the lowest cost path to that node has been found. We all know we generally we have two lists like open list and closed list. In this open list is the implement a priority of queue and it stores the next value to explore. In closed list, it considered where the values already visited and move to the next neighbor. So it remark has a evaluated has visited node. So to find the lowest cost path, a search tree is constructed in the following way. Like we want to follow some set of steps. So first step, initialize a tree with a root node being the started from node S. So we start the node from S, started node as S. So remove the top node from the open list for export. So we didn't consider any heuristic value of starting node. So we directly consider to the top and add the current node to the closest list. We can choose the current node, what we have the nearest node, we can choose that. So add all the nodes that all incoming edges from the current node has child node in the tree. So we can say we add all those nodes which has a cost tree and we want to add into the g of x. So update the lowest cost to the reach the chain node. So we can each and every step we want to update the calculate the nodes and we choose the lowest path and compute the evolution function for every child node and add them into the open list. So after computing the visited list, I will like the process will continue till we found the goal. So here we have example. So consider the following example of trying to find the shortest path from S to G. In this following graph, we can consider here we have a graph called we start the node from S, right? So here we start node from S. So here we can take we have A, B, C, D, E, F, G up to G. We want to find our goal has G and our starting point has S, right? So here we want to travel from S and we want to reach the G. So we have a path. So like we didn't consider in the S heuristic value here. We move from direct to A or B or C, connected neighbors of S. So each edge has an associated weight, right? And each node has an heuristic cost and parameters. Like we can say, each node is usually having a weight curve, some weight of it. Okay, where given C4 and of g of x is a 4, and where h of x like heuristic value of x is on a is equal to 8, like f is of 7, like that. So an open list is maintained in which the node S is the only node in the list. The such tree can no be constructed. Like an open list is maintaining some set of nodes, right? Some set of nodes. So only S is only a node in the list. To such tree can node constructed. Like it is a we call the S as a parent node. So from the parent node, we want to explore all the chain nodes to till we want to reach our goal node. So explore S. Let explore the S. So here we starting node. We here we explore here we exploring the S. So let us start exploring from the S. So here what's the function we also later. So we have a formula here. What's the formula? So I will write 1 second. Here we have a formula here. So for the formula we can take f of x. F of x equal to um, g of x plus h of x. Right? So we have a formula. So for this formula, we can consider here f of x is the main output and g of x is the estimated g of x is the cost, okay, and it is h is the estimated cost of n, and g of is a total cost of actual cost of n, right? Actual cost, and it is a total estimated cost. H is so from here we have a we start from s, right? We start from s here. Quick food. It has a 7 heuristic value. H of x is 7 for us. But we didn't consider here 7 because we are starting node from S, right? So we didn't consider 7 here. So let's start the exploring. So here we have node cost and closed list, and we have how many number of routes is connected to the S. We can calculate those. So we are connecting S as connected to A, right? S is connected to A, and S is connected to B, and S is connected to C. So here we can see here. So here means g of x is nothing but here we can see g of x of a, g of x is nothing but this is the path. G of x of a, right? I'm considering a g of x is this is the number of g of x. We call this as g of x. The in parameter that we are considering it is g of x, and the value of heuristic value of h of x is the value we calculating here h of x. Okay. So here we can say, so we're calculating here 4 g of x is 4 over in f of a. So what is the g of x here of g of x of s to a? So we have 4 and plus we have to calculate the h of x, right? So we want to calculate what the h of x 8. Then we get 12 as an answer. Then we get 12, right? So we consider this 12 as a equal to 12. We consider. So we get the a equal to 12 here. And now for b, we are considering s of g of x as 10 and plus h of heuristic value is 6. So total we get 16, right? So total we get 16 here. So we enter the list in S. Starting we enter the list as S. Okay. So here g of x is 11 and plus heuristic value is 5. So overall outcome equal to 15. Sorry, 5, 16. 11 plus 5, 16. Okay. So here we want in those lines we want to find the common in those we want to find the common lowest path. So where you have 12 is less than 16 and 16 is equal to 16 is less than or equal to 16, like lesser or greater than equal to 16 we have. So here we have less than value is 12, right? So low we want to consider the lowest part, right? So usually S moves to the A. Here S want to move to with A. Okay, here we literally in both A, B, C neighbor we consider the lowest part A, right? So let's we begin with S. S with A. Let us wait. I will clear the screen here. That's okay. So, A is the current most promising path. So, it is explored next. So, next we want to explore. So, from now, A, we want to explore the A here. So, from A, we would exploring A here. So, for X, like we can see in previous part, we move A direction, we choose the direction as A to S, right? So, in this, we want to choose any of the direction to the get nearer. So, same concept here. So, this is the f of x is here. Sorry, this is the g of x. The g of x, and here this is the heuristic value h of x. So like that we can calculate. So we can calculate our f of x with, right. So g of x equal to 8. This here we want to calculate it. SA equal to b, right. SA equal to, here we considering S and A both because we travel S to A, right. So we consider both. So again here we calculate the S of A to D. S of A to D. So here we consider yes, and close the list we added A, right? Here we already visited here. So this is our current visited state here. This is, so here we can choose. Here we can calculate here. So we can calculate like we have the f of x. How many g of x? You can calculate all those because we have f is one g of x, and for A to B we have the travel 8. So we have another g of x. We can also calculate previous or in current and previous. So again now h of x is 6. So total outcome of B, we get 18 here. So 8 plus 4, 12, 12 plus 6, 18, right? We get the value of 18 here. Again, we want to calculate here S of A2. So S of A is of again 4. We have A to 8 is 5, and again plus 5 H of X is 5, and equal to 10, 14 here. We get the D equal to 14. So obviously, obviously, we choose the easiest part, right? So we choose here A to D. Next we travel SA A to D because A has the lowest value because in 18 is compared to 18 is greater than 14, right? Sorry. 18 is greater than 14 and 14 is less than 18. So we can consider with 14 here because 14 is the nearest path here. So we can consider 14 here. So here in the graph note what you think here. So or if approximately we get the B has 18 here and D has 14. But what the remaining value of B, C, D 16? So this is the actual of this cost. Okay, so here we have 10 and 16, right? G of x is 10 and our h of x of this B. We are talking with this. Talking of this B. Okay, so here 10 plus 6, right? We get the value of 16, right? We get the value of, so 10 plus 16, we get the value of 16, right? We understand 10 plus value of 16. So same like that, we get the value here too. So same here, we get 11 plus g of x actual cost and the estimated cost is 5 heuristic value. So here we get this value and we get the output as, so we get the output here 16, right? So we added q in list. No, we move to the next explorer. So now we reach S2B and B S2B and B2A, right? Sorry, S2A and A2D, right? So here we want to explore, now we want to explore the D. We already explored A, B, C. Right? In this A, B, C, we choose the lowest path as A, right? Because it is the lowest path. So after that we choose B and C and then we lowest path is G. So we just, so here we D we have H, I, F, right? H, I, F we have the values. So from here we want to explore like same process. Here, whenever we extra word is adding extra additionally, we want to consider those words. So here we travel from here to here and here to here, and now we want to select where we want to travel. So we can take S of A, S of D here again because we consider both g of x value, right? We want to consider the all the g of x value to what to h. So this is our g of x value. So all those we want to consider here g of x value of here and heuristic value of h is 7, right? So here we consider both s of d and s of I and same here s of d here. Sorry, s of a b sorry a d and here f. We want to explore those nodes. So in that we want to choose the nearest node. We can let's calculate the nearest node here. So we can see here. So what the my g of x value of 4? It is 4. After that S2 A2. Yes, we get the 4 and A2D. I want to calculate the 5 and 5 2. I want calculating the here. D this H, right? So here I want to calculate now. So I was calculated because initial we starting value we considered as 0. Because we only calculating here g of x. We did not calculate the heuristic value of starting here. Okay, we does not calculate the starting value here of estimated cost because we didn't consider sorry doesn't consider that because we are starting from there. No? Whenever wherever we starting node, it gets 0. How much value it has, it's necessary none of above. So it always remember has starting node has 0 only. So then 4 and then we get the 5 and after that we want to travel right we get 16 here. So for the equal we get 20 approximately here. for 2025. We get HS 25. Wait a second. I want to get the HS. Okay, okay, wait. I want to add another value here. I want to add 7 here again because I does not calculated here 7, right? So I will, okay, check it. I will calculate 4, 5, 16. This is my SAD G of X values and my H of X value is this, right? For that, I would get the calculation of 32. Okay. Like this, we are calculating the all the nodes of this. So here what we get here, I we get 33 and F will get 18. So here 32 is less than 32 is less than 33. Okay, and here also 33 is greater than 18. So here we have both less values. So in this almost we can say 18 is the lowest value, right? So we choose 18 as the lowest value. We enter the D here because we already visited it. Now our lowest value is D. So let me consider with F. We do consider with F because F is the lowest value comparing to the HIAF. Now we want to explore the next node. So we want to explore the G node here. So now explore F. When like that in the process of till the end, we want to explore those nodes here. Now we are how we process here. Like we travel S2 here A and A to D we traveled and D to F we were travel and F to G we reach out goal set because F has only one neighbor. Okay, here we can calculate like this. So we have the 4 of G of X of like we calculate here like this. Yes, A, T and F. This is all over G of X values. So here we have the calculation here, other value. So here whatever h of x is 0. G is our h of x and it has 0. So we calculate those values. So S of E, S2A consider 4, cost is 4 and A2D the cost is 5 and D2F the cost is 1, right? S2A we consider 4 and A2D we consider cost as 5 and D2F we consider as 1 and the overall cost of F we get here. So 0, right? 4 plus here we get 10. 10 and G state. Now we reach the G state. So here we have another twist here. So we get overall this, but we didn't consider F2G, right? So we have the cost of F2G also. We want to calculate that too. So 10 plus, so 10 plus 13. We get G equal to 23. G equal to 23. As we reach our goal state. We reach f of x. What is the f of x? We reached our goal state here. We have f of x of total cost, actual cost, and plus estimated cost. We get the result as 23. 23, right? The G is nothing but G here. So this is the value we consider here. We reach the goal state here. So like this, we consider here, we follow the A star search graph algorithm in AI. So it usually used in most in traffic, route finding path, shortest path finding directions is used to. So you notice that the goal of node G has been found, however, is not been explored because we want to explore the 6G also, because if we reach the G state, we can check the either any neighbors or there existed or not for the G. So the algorithm continues. So the algorithm continues because there may be a shorter path to the G, but the node B has two entities in the one open list, right? So one cost of 16 child of S. So one of the cost of the 18 child of A. So the one who with the lowest cost is explored next. So here we can check that. So here we can check that we have the lowest cost here, right? We have the lowest cost here. So B has one of the value of here 10 to 1625. It has approximately some value here, right? So how much B consider 18 here for D it considering so value. So it has a one neighbor, it has a C has a only one neighbor. So A has a child of 18 of child cost of 18. So, however, we consider G because we want to explore the G2 because we want to check any neighbor is existed or not for G. If we in this search, what we considering like if you reach the goal state, we doesn't consider to the next. Yeah, we reached the goal state, we close our algorithm is completed, our task is completed, we find the goal. It also explores the G2 because it checks the where G has any node or any neighbors to closest right. So it explores the C again because doesn't check C, right? Because in the next in previous graph it doesn't check C here. So already in first graph we can see has C. It doesn't explore C, right? We have to stop from B and we explore it starting. So in starting is we explore it direct to A, right? We explore A, B, C, but directly we started from the A. We doesn't consider here right? Yeah, right. So we want to check any other existing shortest path for B side to or C side. Like that, we want to check. We have so we find the distance. We get the 23 estimated. We get the f of x as 23 for the A side. We want to same calculate from the B side and C side where any connectivity in between these so to get the shortest path or not. So we explore the D and we get the value of here and we explore the 10 and 15 and 10 and 15 to 25 and 25 here we get the heuristic value of it 5 and 30 so considering so we want to explore here C again. We explore the C here. It also get D, E, F. So we choose here shortest path. We want to choose another shortest path here. Like same G of X is 8 and H of X is 5. So it D consisted here considering of D. We want existed in D because we want to explore all the nodes. Okay. After reaching goal state also, we want to check if any possibility to in the next any possibility of another lowest path to find the direction easily. So here we can say 13D has get 13 and E has get 23 and F has get 5. So your shortest path is again F. We consider again you get F here. So the next node in the open list is again B. So however, because B has already been explored, meaning there the shortest path had to be B has been found. So it is not explored again, and the algorithm continues to the next candidate. So we already explored here all the nodes and continuously. So line by line, we are executing those nodes here. So we find the next node to be explored in the goal node is G. So meaningly the shortest path is G. We find the G. No other connection has been found. The path is constructed by tracking the graph backward for the G to S. Again, it finds the shortest route here S to A to D, D to F. Again, it backtracks to the parent node S. So this is the process of finding the such A star such algorithm. I hope you guys all are understand in the theoretical way of how the algorithm works and its behavior. So in next lecture, we will discuss this same problem in a practical way in coding. So until that, bye all of you.